Here are the answers for the Chapter 5 review that is on page 202. It's not the answers to every question, but any of them that requires math procedures. Number 3, what goes in the parentheses? This has a negative exponent, and it's being transformed to have a positive exponent. That means that a reciprocal was taken, so you turn the fraction upside down. Number 4, simplify this. The m to the 0 portion is equal to 1. Then we have 6 times 1 on top, which is 6, divided by 2, which makes 3. Number 5, we have a bunch of things in the parentheses and this exponent on the outside. We can distribute that exponent to every factor inside, starting with the 1/2, then the s, then the r. So we would have 1/2 raised to the -3 power. Now the letter s, and that will be to the 9th power. S already has an exponent. We want to raise to another exponent, so you multiply the exponents. The same for the letter r. When you multiply the exponents, you get -6. Since you don't leave final answers with negative exponents, let's apply the negative exponent rule, which is to take a reciprocal. So flip the 1/2 upside down, it becomes a 2, and now it goes to the 3rd power. Keep the s to the 9th power. For the letter r, make a reciprocal, 1 over r, and now it goes to the 6th power. Final answer is 8 s to the 9th over r to the 6th. Number 6 is a dividing problem. You subtract the exponents. So you write the base x and then subtract the 2 exponents. Be careful with the subtracting a negative. This makes x to the 6th power. Number 7, the very first thing we're asked to do is to rewrite this so that the denominator is a 1. That means that anything that's in the denominator needs to be moved. For example, instead of having 3 in the bottom, we could put a 1/3 in the top. The h to the 0 is just equal to 1. So we don't need to write that in the bottom. There are also h's in the top. Let's leave them up there. The k to the 2 can be written in the top if you use a negative exponent. There are m's top and bottom. So let's use the rule about subtracting the exponents. -1 subtract -2 is +1. So we get m to the +1. The letter t is in the top and bottom. Let's subtract the exponents. -6 subtract -3 is -3. Now there's just a 1 in the denominator. For question B, we're asked to rewrite it so that there are no negative exponents. So here's the fraction bar. In the bottom, there is a 3. Let's look at the letter h. The h to the -2 can be moved into the bottom if you use a positive exponent. When you combine that with the h to the 0, there is h to the 2 in the bottom. The letter k is already in the bottom and has a positive exponent. Leave it alone. The m to the -2 that's in the bottom can be moved into the top using a +2. Combine that with the -1 that you already have, and you get m to the 1. Now let's look at the letter t. The t to the 6th power can be moved into the bottom if you make it t to the +6. Combine that with the -3 that's already down there, and we have t to the 3. So this answer has no negative exponents. For number 9, we're asked to figure out what numbers are restricted values of x. That will occur if there's a variable in the denominator, and there is. We do not want the denominator to turn out to be 0. Now let's factor the denominator, x times x minus 4. Again, we don't want that to be 0. There's 2 different values of x that would make this be 0. We don't want x to be 0, or we don't want x to be +4. Number 10, take the denominator and indicate we do not want it to turn out to be 0. This trinomial factors as m plus 3 times m minus 1. Again, we don't want that to be 0. There's two numbers for m that would make it be 0. So we want to indicate that m cannot equal -3 or m cannot equal a 1. Number 11, there is a variable in the denominator, but no matter what you plug in for w, as soon as you square it, you're not going to get a negative number. And then when you add 4, you're for sure not going to get a negative number. So this time there are no restrictions on w. Number 13, we're asked to simplify the expression. Let's first factor it to see if anything cancels top and bottom. In the top, there's a GCF of Rx. Rx times 4r squared is the 4r cubed x. And Rx times -1 is the Rx. This 4r squared minus 1 is a difference of squares. It factors using two sets of parentheses. We have 2r plus 1 and 2r minus 1. In the bottom, the denominator also factors. There is an x in both places. So we can write x times 2r minus 1. And let's carry over that factored form over to here. Now look to see what cancels out. The x and the x and the 2r minus 1 and the 2r minus 1. So the final answer is r times 2r plus 1. Number 14, let's factor the top. The trinomial will factor as d minus 1 squared. The bottom also has d minus 1 squared. These will cancel each other away, leaving 1. Number 15, let's factor. The top is a difference of cubes. The pattern is a smaller set of parentheses than a longer set. H minus 4. I got the h by doing the cube root of h cubed. I got the 4 by doing the cube root of 64. Then we have h squared plus 4h plus 16. I got the h squared by squaring the h. I got the 4h by timesing those two together. And I got the 16 by squaring the 4. In the denominator, we have a difference of squares. So the pattern is two sets of parentheses. H plus 4 times h minus 4. Is there any reducing? Looks like the h minus 4's cancel away. So final answer, h squared plus 4h plus 16, all divided by h plus 4. Number 16, we have dividing and timesing of fractions. The first step is to rewrite it and change the dividing into multiply. So 18 over 35 times 56 over 45 times -75 over 32. Now let's try to reduce to make these numbers a lot smaller before we times them. 18 and 45 both divide by 3. 18 divided by 3 is 6. 45 divided by 3 is 15. 56 and 35 both divide by 7. 35 divides by 7, leaving 5. 56 divides by 7, leaving 8. 8 and 32 both divide by 8. 8 divides by 8, leaving 1, and 8 into 32, leaving 4. 6 and 4 both divide by 2. 6 divides by 2, leaving 3, and 4 divides by 2, leaving 2. In the bottom, a 5 and a 15 is 75. 5 times 15 is 75. We can use those together to cancel the 75, leaving -1. I don't think there's any more reducing, so in the top we have -3, and in the bottom, a 2. Number 17, we have another timesing of fractions, but before we do anything, let's rewrite it and take care of this negative exponent. So I'm going to copy the first one exactly the same as it was. keep it as times, and then flip over the second fraction. Now before we multiply anything, let's try some reducing. 32 and 20 both divide by 4. 32 divided by 4 leaves 8. 20 divides by 4, leaving a 5. 8 and 4 reduce by 4. 8 divides by 4, leaving 2, and 4 goes into 4, leaving 1. Now let's cancel some c's. We can use both of these c's to cancel 2 of these away, leaving a new exponent of 2. Let's cancel some d's. Both of these cancel away 2 of those, leaving a new exponent of 1. In the top, we have 2c to the 10th, and in the bottom, 5d to the 1. Next, number 18, we also have timesing fractions. But to see if anything reduces, we need to have factored form. I know it's going to be easier for me to factor this if I put it in standard order, where the x squared comes first, then 64. Similarly, I'm not happy with how this denominator is not in the right order. So my very first step is going to be to rewrite this question. I'm going to put the negative x squared first, and then the positive 64. In the bottom, I'm going to put the negative 2x squared first, then the plus 13x, and then the plus 24. And keep the second fraction the same as it is. Next, let's work on factoring. Because this starts with a negative, we can factor out a negative sign, leaving x squared minus 64. The same in the bottom. Because this starts with a negative, we can factor out a negative sign, leaving 2x squared minus 13x minus 24. And then keep the other fraction the same as it is. Negative over negative is going to cross out. Now, these factor, so I'm going to rewrite them in factored form. Right above this, we can write x plus 8 times x minus 8. That's the new numerator. Underneath this trinomial, we can write 2x times x, and in these spots, we can put a positive 3 and negative 8. That's our new denominator. Right up here, let's factor this. 2x times x, and then positive 3 and negative 1. That's the new numerator. And then let's factor this denominator. There's a GCF of 3x, leaving x minus 8. That's our new denominator. Now let's see what crosses out. X minus 8 crosses x minus 8. 2x plus 3 cancels 2x plus 3. In this blank spot here, let's put our final answer. In the top we have x plus 8 times x minus 1. And in the denominator, it looks like we have 3x times x minus 8. Number 19 is a division problem, so the first thing we need to do is rewrite this as multiplication. So let's keep our first fraction the same. Change to times, and flip the second fraction upside down. When I flip it upside down, I'm also going to rewrite this 3 minus y so that it's in the correct order, the negative y, and then a plus 3. In the bottom, we have the y squared minus y minus 6. Now let's rewrite this in factored form, starting with this first numerator. We can factor out a y to the 5th power, leaving y minus 2. In the denominator, y to the 4th minus 16 is a difference of squares. This makes y squared plus 4 times y squared minus 4. But the y squared minus 4 is a difference of squares itself. So this denominator really can be written as y squared plus 4 times y plus 2 times y minus 2. So let me cross out this old denominator and think of this as the denominator. Now times. We can pull out a negative sign, leaving y minus 3. And then in the bottom corner here, this factors as y minus 3 times y plus 2. Let's see what crosses out. Y minus 2 cancels y minus 2. Y minus 3 cancels y minus 3, leaving a negative 1 left over. I don't see anything else that cancels. So in the top we have negative 1, y to the 5th. And in the bottom we have y squared plus 4 times y plus 2 squared. Make sure you see why I said squared on the y plus 2, because there's a y plus 2 in this denominator and another y plus 2 in this denominator. In number 21, we're asked to figure out what would be in this numerator if these fractions are equivalent. Well, it would sure be easier to figure out the numerator if our equivalent fractions had the same denominator. Because if the denominators are the same, then the numerators have to be the same. Let's get a common denominator. This first one we can factor as 2 times 2a plus 1. Let's also factor this one. This makes 3 times 4a squared minus 1. But 4a squared minus 1 is a difference of squares and can be written as 3 times 2a plus 1 times 2a minus 1. This helps us to see the lowest common denominator. If this is 2 and this is 3, then the LCD is going to have a 6 in it. There's also a 2a plus 1 common to both. But the LCD also has to have a 2a minus 1. So to make the first fraction have that common denominator, we would need to times by 3 times a minus 1, and in the top. To make this denominator be the common denominator, we only have to times by 2, and in the top. What does this turn out to be over here? 3 times 3 is 9 times a minus 1. What would you times by 2 in order to get 9 times a minus 1? Let's temporarily call this x, just to call it something. We know that 2 times x has to equal this numerator over here, which is 9 times a minus 1. That means x has to equal 9 halves times a minus 1. We were using x to be that unknown numerator. And so here's the answer for that numerator. Number 22, we're adding fractions. We have to have the same denominator. Let's put the denominators in factored form to help us get the LCD. This denominator is 3 times c minus 3. So let's cross it out and think of it as this. I don't like how 3 minus c is written out of order. 3 minus c is the same thing as the negative of c minus 3. So let's cross this out and think of the denominator like this. Another thing we can do is instead of having the negative sign down the denominator, we can put it out in front of the fraction. In essence, changing the plus sign to a minus sign. This helps us to get a common denominator. We can see that it's going to be 3 times c minus 3. The first fraction already has that, but this one here would need to be times by 3, and in the top. We should put c minus 2 in parentheses when we do this. So our new fraction has c minus 3c plus 6. And that's all over the common denominator of 3 times c minus 3. Let's focus in where this came from. The letter c is coming from over here. The minus 3c comes from the negative sign being associated with the 3 and then being times to the c. The positive 6 comes from the negative sign being associated with the 3 and then being times by negative 2. In the top, we have negative 2c plus 6 all over 3 times c minus 3. The top factors as negative 2 times c minus 3. Now we see that the c minus 3's cancel. Final answer, negative 2/3. Number 23, we have subtracting fractions. We need common denominators. If this is 6 and this is 15, the common denominator is a 30. We can make this be 30 if we times by 5 and times the top by 5. We can make this be 30 if we times by 2 and times the top by 2. So we have 15m minus 5, and then think of this minus as being with the 2 when you want to multiply. So negative 2 times 3m is negative 6m, and negative 2 times 5 is negative 10. All over our common denominator, 30. 15m take away 6m is 9m. Negative 5 take away 10 is negative 15. All over 30. Everything divides by 3. So final answer, 3m minus 5 all over 10. Number 24 is also subtracting fractions. We have to have the same denominator. But let's first factor the denominators. This one has a GCF of 2, leaving 2n plus 1. So cross out this and think of the denominator in this form. This is a difference of squares. It factors 2n plus 1 times 2n minus 1. So cross that out and think of that denominator in its factored form. Now we can see the LCD. It has a 2, it has a 2n plus 1, and it also has a 2n minus 1. So the only thing missing in the beginning is the 2n minus 1. Let's times top and bottom by that. This one over here is missing the 2. So let's times top and bottom by 2. Okay, we're going to rewrite the problem. And it will now have a common denominator in the bottom. 2 times 2n plus 1 times 2n minus 1. n times 2n is 2n squared. n times negative 1 is negative 1n. 1 times 2n is positive 2n, and combining together is positive n. And then 1 times negative 1 is negative 1. Now we're minusing. n times 2 is 2n. Let's rewrite the top. 2n squared minus n minus 1. And that's all over our denominator. This numerator factors as 2n times n, and then a 1 here and a 1 here, and then a negative here and a positive here. So cross out this numerator and think of it in its factored form. Now let's look for reducing. The 2n plus 1 cancels 2n plus 1. And that's everything that reduces. So final answer is n minus 1 over 2 times 2n minus 1. Number 26 is a complex fraction. You can think of this as having a 1 underneath and a 1 underneath. The technique is to times all 4 parts by the LCD, which is 2a. So times everything by 2a. If we did this correctly, then all our denominators will cancel. The a cancels the a. The 2a cancels the 2a. We're left with 1 times 2, which is 2, minus 2 times 2a, which is 4a, all over, right in this spot, just a 1, and then minus, and then in this spot, 1 times 2a is 2a. Let's do some factoring to see if anything reduces. It looks like we can cancel the 1 minus 2a's. Final answer is 2. Number 28 is also a complex fraction. Think of this as having a 1 underneath and this as having a 1 underneath. Now, what's the LCD? It's got to have a 3 in it because here's a 3, and later on it's got to have an x squared. So the LCD is 3x squared. Let's times everything by 3x squared. If we chose the right denominator, then everything's going to cancel. The 3x cancels the 3 and 1 of these x's, leaving 1x left. The x cancels 1 of these x's, leaving 1x left. The x squared cancels the x squared. 3x times 3x squared is 9x cubed, minus, and then 1 times x to the first is just an x. 3 times 3x squared is 9x squared. And then we have plus. 7 times 3x is 21x. And then we have a plus. 2 times 3 is 6. Now let's factor these to see if anything will reduce. We have x times 9x squared minus 1. In the denominator, they all divide by 3. We're not done because this is a difference of squares, and this trinomial probably factors also. So we have x times 3x plus 1 times 3x minus 1. In the denominator, we have our 3, and then 2 sets of parentheses. 3x times x, and then to make 2 is going to be 2 times 1. Let's put the 1 here and the 2 here. Now check for any reducing. 3x plus 1 crosses 3x plus 1. I think that's the only reducing. So we're left with x times 3x minus 1. And in the bottom we have 3 times x plus 2. Number 31. You can do a job in 2 hours. Your friend can do it in 3 hours. Working together, what part of the job can you both do in 1 hour? This is about work, which is equal to rate times time. Let's figure out our rate of work and our friend's rate of work. So first of all, our rate. If it takes us 2 hours to do the job, then we can do half the job per hour. Now let's do our friend's rate. If it takes her 3 hours, then she can do 1/3 of the job per hour. Working together, what part of the job can we both do in 1 hour? We get to add together how much work we do plus how much work our friend does. So we do half the job per hour, and we're timesing by 1 hour. Plus, our friend does 1/3 of the job per hour and times us by 1 hour. This makes 1/2 plus 1/3. When you get a common denominator, this is 3/6 plus 2/6. Together, we can do 5/6 of the job. Number 36. 60 ounces of a 15% ammonium chloride solution is mixed with this stronger solution. How many ounces of the stronger solution should be used to obtain a mixture that is 40% ammonium chloride? The question asks us how many ounces of the stronger solution. Let's represent that with a variable. So ounces of the 70% solution. We could pick X to represent that. Now let's take those sentences and try to create equations. 15% of 60 ounces is ammonium chloride. That can be written as 0.15 times 60 ounces. We're told we're mixing that with something, so we're going to add more liquid. 70% of the number of ounces of that new solution is ammonium chloride. When we mix them, we're told we're going to get a 40% solution. So 40% of the number of ounces is ammonium chloride. This equation models the situation, and it has only one variable in it. Let's solve the equation. 0.15 times 60 is 9, plus 0.7x equals 0.40 times 60 is 24, plus, and 0.40 times x is 0.4x. Let's subtract 0.4x from both sides, and subtract the 9 from both sides. We have 0.3x equals 15. Now divide by the 0.3. We get x equals 50. And x was representing the number of ounces of our solution. So we'll just put ounces next to that. Number 41, we have an equation to solve, and it has fractions. So the technique is to multiply everything by the LCD. Let's first rewrite this denominator so it's in the correct order. Let's think of it as negative 2n and then plus 2. Now let's factor that as negative 2 times n minus 1. We can remove the negative sign if we change this plus sign to a minus. Now we can see that the LCD is going to have 2 and n minus 1. So let's times this by 2 times n minus 1, times this by 2 times n minus 1, times this by 2 times n minus 1, and times this by 2 times n minus 1. Now let's look for reducing. The n minus 1's cross out. The 2 times n minus 1's cross out. Our new equation is 2n squared plus 2, then plus 2n minus 2, then minus 1 minus 3n, and then equals 0. Let's combine like terms on the left side. We have 2n squared minus n minus 1 equals 0. And factor this. 2n times n, 1 in 1, a negative here and a positive here. Now solve these. This makes n equals negative 1/2. This one makes n equals positive 1. Now we need to check if any of these are restricted values. Using negative 1/2 is okay because when we plug that in the original equation, it doesn't make a 0 in any denominators. But we can't use n equals 1 because if we put a 1 right here for this n, then 1 minus 1 would make 0 in the denominator. Let's cross that one out. This first answer solves the problem.